Hi, everyone, and welcome to today's webinar, Leveraging MLOps in the Enterprise. My name is Anna, and I am on the marketing team here at Anaconda, and I will be moderating today's event. While we give everyone a few moments to get settled in, I am going to go over a few housekeeping items. We will be recording this webinar, and the link will be provided to you via email tomorrow, so keep an eye out for that. You can download this slide deck along with other helpful links and resource items from the resource list on your screen. So I would recommend doing that before the webinar ends today. And if you have any questions throughout this webinar, feel free to post them in the Q&A box on your screen. We'll try our best to answer as many as we can, either during the presentation via chat or after with our speakers in the live Q&A session. If you are interested in joining other upcoming events and webinars, check out the website anaconda.com/events. And that is it for housekeeping items. So I will pass it over to the team here to get started.
Hello and welcome to our webinar today, Leveraging MLOps in the Enterprise. A couple of colleagues of mine and myself are very excited to talk to you about such a great topic. I'm going to go ahead and introduce ourselves. I guess I'll go first since I'm already speaking. My name is Chris. I'm a director of product management at Anaconda. I have a background in machine learning, AI strategy, also software engineering, and I'm based in Salt Lake City, Utah. Connor.
Hi there, my name is Connor Gunn. I'm a product manager here at Anaconda working on our enterprise data science platform. I have a background in data science and mathematics, and I'm based in Austin, Texas.
And Josh.
Nice. Yeah. Hey, everyone. Josh. I'm a senior solutions engineer. Work closely with these two gentlemen, these cool guys. We work a lot on the data science platform here at Anaconda. Generally, that entails a lot of platform-related solutions, MLOps, and delivering in a number of different very cool scenarios. Based out of Seattle, you can see me in the cool picture there. I'm doing some paddle boarding.
Awesome. All right, thanks everyone. So we're going to be having we're just going to be having a chat about MLOps today. We have a few questions that we're going to use to seed the discussion, and hopefully share some really interesting tidbits for everyone. So first thing that I wanted to do is just set the stage and talk about how we do machine learning. And when I say we, I mean the royal we, right? Data scientists, software engineers, knowledge workers, business analysts, product managers, business leaders, CROs, everyone. So we think about the idea or the question that we're asking, that we want to use machine learning or use AI to answer or to help us out with. We then generally take a bunch of data together and we compile something called a model and build that machine learning or that AI implementation, and take that from what I built into production, right? So that it can actually be accessible by me, by my users, by my company, by my team, by the public, whomever. That is generally the most difficult part, which is why we're talking about MLOps today. And then once that deliverable is put into production, then it can start to provide value, right? It can start to provide recommendations or fraud detection or risk management or anything like that. This is a Gartner diagram that I like to just throw up when I talk about MLOps. And this looks at really the whole ML AI lifecycle. So what we're going to be talking about today is really going to be this point in the middle that says model management system. So that's one of the systems we could be using to do MLOps. All right. A couple of challenges that we like to talk about. So training and development can be very arduous if I don't have a standard framework. But the biggest one is number 2, and I guess we should put this number 1. Model deployment to production takes up 80% of my time. So this is, in my experience as a product manager doing AI, doing ML solutions, this is proven to be true. because the whole ML operations and the deployment to production problem is still something that presents a lot of challenges to really every organization that I've worked with, right? And so the idea behind performant MLOps framework is to be able to accelerate and to automate away a lot of that complexity. All right, so let's start with our first question. What is the full ML lifecycle? And before we take it away, I'm just going to go use one of these slides that we throw up here. So I'm going to hand it over to you two gentlemen, and I'll add in points as I see fit.
Oh yeah, absolutely. Connor, I'm going to dive in. I love the model development lifecycle. Yeah. So yeah, this is a great diagram. It very much models what we see with the software development lifecycle, where you really have this repeating process. And again, I do like to reiterate that it is an iterative process of developing something, and then you manage what's the result of that in some sort of usually through versioning of something. With machine learning, since it's kind of a mix of code and binary artifacts, it does get a little bit more interesting compared to standard software development. But just like standard software development, after you have something, you do need to deploy it. And then the most important part to kind of bring things full circle is instrumentation or monitoring, because that really does allow you to do business analysis. Once you've got your solution out there and you really want to say, hey, is this working for us? That's part of it. And so one of the things that really isn't called out here, though, that I think is really important is project scoping. So before you even build or develop it, what is it that you need to do? And generally, if you have already gone down this journey, you probably have something that already exists that isn't a machine learning based solution. And that is very often a first step. You create something that's a classical computing solution, and then you see, hey, this actually really does qualify for a machine learning based solution can be applied to it. Generally, then after that, the other thing that I really like to call out in addition to this is data engineering or feature engineering, since you do often iterate a lot on the model or the type of model or your hyperparameters, but data is so important that you will spend a lot of your time as well iterating over data and your features as well. So, gosh, I find feature engineering to be very interesting and very important. Want to make sure that was called out.
Connor, what are your thoughts on this?
Yeah, I mean, a big thing here that really stands out to me, I think a lot of times is going beyond just having like that sort of build and that going from the data and like building a model, right? That this step that we're really digging in today is going to be around like that management. How do we keep track of everything that's going on, getting out of the code, right? Not just having things sort of that we're working in our editors, but also going beyond and sort of understanding every step of the process and making sure that we have good tracking and taking a look at things over time. I really like this diagram here as well, because it kind of takes that flow that we were looking at earlier that Chris showed in, I think, one of the first slides, and make sure, it really illustrates it as that cycle, right? Once you understand those questions, right, you learn a little bit more about a situation, and then you start to sort of repeat that process with a little more extra context and improve that cycle.
Cool. Yeah, really the only thing that I would add, or I guess reinforce, is that a lot of times, yes, machine learning and applied machine learning has been around for a number of years now, but I actually still consider it to be a pretty nascent technology. It's something that when we talk about things like a software SLDC or like a delivery lifecycle, we're still figuring out how to automate and how to remove the complexity from a number of steps in the ML workflow and in the lifecycle. And so I think a lot of teams and companies that I've worked with, right, they scope it, they understand, they analyze, and then they build and develop, right, and they come up with a model. Maybe they have something that they can put Excel spreadsheets through, or that they can have a very simple interface on. But it's really that step about bringing that work to life, right? That's where I see most of the implementations fall off or even fail, right? There's some pretty, startling statistics that are really all over the place, that paint a pretty grim picture about the percentage of data science and ML projects that actually make it to production. So with MLOps, that's something we can help you do. All right. Let's go ahead and go to our second question. So this is a doozy. How do you define?
There's three here.
Why is MLOps important, and what can you achieve with MLOps? And so we're just going to use this seed slide here, and yeah, Connor and Josh.
Well, again, Connor, I would be happy to jump in. So MLOps, really, it's kind of an extension or an application of DevOps from standard or classical software development, but in the ML space. So DevOps, again, is a combination of development and operations, and it's a set of, best practices for software development. So what is MLOps? Well, MLOps really is leveraging DevOps and ML best practices to productionalize ML, or bring ML to production. And so this would include things like CI/CD for the continuous delivery and continuous integration. Because again, since this is an iterative process, as much of it that can be automated as possible, the better. You would see monitoring, telemetry added to it, so that you can actually see the results of the work that you have. Code and models are all versioned. Generally, these are in source control of some kind, or in a model registry as well. This helps you track, essentially the heritage of the models and back to the data it was trained on. Additionally, the other thing I did mention around monitoring is tracking the things that are really, really important. So as a machine learning scientist or a data scientist, pardon me, you are going to be working with experiments a lot, and you're going to be tuning models. So getting model metrics, hyperparameters, and having all of that so that you can go back and look over it and report on it as you make those decisions, I think are really important. And I think those are really integral to MLOps and the success of it.
Yeah, I think, you definitely defined it very well. I think the part that I'm going to hit on is why is it so important? And I think that 2 points here, right, about bringing machine learning to life, that's where the value is, right? A lot of times when we're working with machine learning models, or even just in software in general, there are a lot of folks that we're interacting with in a business sense, in an enterprise setting, that aren't going to be as technical, or aren't going to need to have access to the same levels of code that we might be sort of organizing in our organization, and bringing the availability of that data, the availability of that model to the wider organization in a way that's consumable is really something that's valuable in the MLOps process. A lot of times we won't want people sort of digging around in code, or we won't be sharing data, or even just like taking something that's sort of like a model that is existing only within our own notebooks, and making it into something like a dashboard or an API that can be used by a larger organization, is a big step that really helps to sort of bring a lot of value and help answer those questions for folks that may not be as heavily involved in that development process. And then sort of helping our own teams understand where those things have gone, where that data has come from, right? Without having to sort of look through my own, infrastructure and databases, right? Not having to have all of that knowledge, while still being able to gain value from all of the things that our data teams are working on.
Right. Gosh, couldn't have said it better myself. Yeah, I mean, I think that MLOps is to me is the unsung hero of teams, organizations, companies that really makes the difference between organizations that are trying to do ML and that are actually doing ML, and that have they're seeing a lot of success. There was something I was reading about Chase, the large, JP Morgan Chase, the large banking financial institution, talking about that they have literally thousands of people doing AI and ML, and they've actually automated some of their, key and core financial operations are completely in the hands of AI these days. And to be able to do that, you have to have MLOps. So,
actually,
right.
More big point actually that I'd like to talk about too. With the sort of rise of data science, machine learning, AI, everything in the last few years, so many organizations are starting to pull together or have pulled together these data science and ML teams. And if you have sort of a team that's working off, kind of doing their own thing, like doing their machine learning practices, but if you're not able to sort of communicate out, a lot of parts of the organization may not be able to see that value, right? Why are we sort of dedicating these resources to our ML projects when we have other stuff going on? Whereas ML ops can really help sort of like elucidate why that team is so valuable, right? What does data science do for our organization broader than just my my data science team, right? And that can be very, very helpful in sort of those organizational conversations.
Thanks for that, Connor. All right. Our third question, what are the top things that define a high performance ML ops operation? This will be an interesting one. Who wants to go first?
Yes. I'm willing to go.
Yeah, go for it, Josh.
So I think that getting ML to production is mostly an infrastructure problem. So I think what you see in really high performance ML ops solutions and teams are a really broad set of skills and tools to support data science. What that really means, I like to think about is breaking it down to observability and interpretability. So observability would be, hey, what is my entire system as a whole doing? And you would be able to see that like a high performing MLOps solution would reinforce this by helping you gather telemetry, providing logs, and a tracing solution of some kind. So that you can kind of say, hey, I want to look at this entire system and understand how the components fit together and work. And then with interpretability, that's really just why is the model doing what it's doing? So the ability to look back at what you trained it on, correlate it to the data that was used in that data set. Even the ability to look that proper best practices were used, such as like proper splitting of data into test, validation, and training. I would tend to see that as part of this.
Yeah, I think Chris mentioned it earlier as well, but sort of that automating away the complexity, right? The more time that your team spends on, setting up infrastructure, connecting the databases, setting up all of those, like the backbone, your scaffolding that really helps that data science process, the more time you spend doing that is the less time that you're really spending getting those valuable insights for your organization, right? Being able to sort of see the things that you really like, ask those questions, right? Learn things about the data, learn things about your users or your platforms, and sort of a high level MLOps team, high level data science team is going to have all those things sort of taken care of, right? We want to have those things smooth so we can focus on looking into those insights, right? We can get our APIs set up, we can ask those questions and get answers as quickly as we can.
Shoot, I took most of the words out of my mouth here. Yeah, I've seen. I mean, I've been doing ML both from the practitioner and the team leader side, and then also from the side that we are in Anaconda, where we're providing the tools and the platform and the capabilities to do ML. And gosh, I can say I've certainly experienced being part of teams where we struggled to be high performance, right? And most of the time, I mean, it does, and I'm just going to three-peat on this, it really comes down to managing away the complexity of the infrastructure, right? Infrastructure, I don't know about anyone else, but I know that as a technologist, as a software engineer, when I have to deal with infrastructure concerns or capabilities, that's somewhere where I definitely hit a rough patch, right? And so having to do things like, I don't know, set up airflow capabilities and, work in Spark Shell and things like that are not necessarily things that I want to be doing as a practitioner, or things that I'm even skilled to do, right? And so having tools, having like push button tools or even command line tools, right, that can help me automate that, that is what I've seen to be the difference between high performing and teams that we've had challenges on. The last thing that I'll say is this is something that is extremely difficult within small engineering or within small organizations, is having some sort of ML engineering capability, right? So I know that like there's this kind of joke in the industry that the ML engineer, well, it's a title, but they're like unicorns, right? They don't actually exist. And teams that I've been on that have ML engineering capabilities, maybe it's not a dedicated ML engineer, but it's having those capabilities between your infrastructure team and maybe your data scientists or your software developers is something that can be very helpful.
Mm-hmm.
All right, let's get to our last question here. Why is model monitoring so important and so difficult? And Josh, you did bring this up as one of the areas where
it is
life cycle.
Yes. Yeah. So monitoring, very, very important. I would also say it's more difficult in this domain than it is in classical computing, specifically because we often are working with very heavy or data heavy interactions. So you kind of have to monitor, is my data changing, or is the performance of my model drifting because we're experiencing data drift? Is the model that I trained, is the data representative of the production data? And so always keeping an eye on that it's big. And so having the tooling or the monitoring and the instrumentation there to help with that is also super important. But it also means that you need to kind of think about data sampling. Like if a lot of data is coming in, say like user recommendations, you want to also be able to capture like feedback. Was that a good recommendation? Did the user thumbs up it or thumbs down it? So again, hitting on recording the right pieces of telemetry so that you can actually validate that yes, the monitoring is good and it's appropriate. I think it's a big challenge in this compared to other things. The other part of this that makes it so important is that generally with machine learning systems, you're always trying or striving to create something that's continually learning. And usually this kind of starts out with hey, I trained this by hand the first time, it's great. And then you're like, well, let's automate that. And so you're like, yeah, let's automate it. And so now you have it automated. And now you're like, well, sometimes retraining on all your data takes a really long time. And so you'd want to use stateful training. And you're like, yeah. So the next thing we can try to do is go and just train on new data. And then after that, again, automate the whole process so that that's all happening and your monitoring is feeding back into that and giving you good results.
Mm-hmm. Yeah, speaking of sort of that hand, that monitoring by hand or sort of developing by hand, training by hand, right? To go back to that sort of automating complexity, right, and making sure that we're keeping track of things. The more time that you're spending sort of tracking and looking into my data manually is the less time I can spend asking new questions, right? Once I have that monitoring in place, once I can see what's going on with my data from a sort of bird's eye view, that frees me up to work on other projects and other questions, and gives me the freedom to not have to worry about those things so much, especially just as data changes so quickly, right? Anybody who's keeping up with the latest trends in data science, ML right now, right? Things move fast, and staying on top of those things for your organization is unbelievably important to making sure that you know that your data is staying strong, your models are still sort of working with the stuff that's coming in. So staying on top of that is really important.
It's model monitoring to me comes down to the bottom line, right? It comes down to money. And this is based on some rather unfortunate experiences that I've had, where machine learning models that that either have a direct business impact, right? Let's say it's for a financial organization that's actually executing trades, or could be a model that's doing pricing, right? So it's putting your pricing out into a real-time market. And holy smokes, if that model, let's say, starts, pricing your widgets below cost, right? Because it thinks what it's doing is right. And that isn't caught quickly, that can have a significant negative financial impact. So, situations where we're doing fraud detection and things, that where a false positive can potentially have, can result in legal exposure for the company, right? That's another one where it's so important to have monitoring so that we can understand what this model is doing. I had it when I was starting off as a software engineer. I worked for a prop trading firm, and we weren't doing machine learning, but we were working with a data model where we were trying to predict pricing, and we actually ended up executing a bunch of trades that we thought were test trades on the floor, like on the trading floor, and we didn't know because we didn't have proper monitoring, and that the trades actually ended up making the firm a lot of money, which was very ironic. But they were not happy with that. So there are just all sorts of different, very sticky situations we can get into when we don't have monitoring. So, and all right. Well, that's all the time we have. We really want to thank everyone for attending the webinar. It was a lot of fun to share our thoughts and whatnot. And yeah, we'll look forward to seeing you out in the wild world of machine learning.
Thanks.